Hello friends, and welcome to part 2 of our other data visuals notes. So last time we looked at stem plots and we started to look at box plots, but mostly we just talked about all of the vocab that goes into box plots and quartiles. So now we're going to use that information. So given the box plot here, we want to find the maximum, the minimum, the median, Q1, Q3, the range, and the IQR. So again, the maximum, minimum, median, Q1, Q3, those are all part of our 5-number summary. I can't spell apparently. And those are the numbers that we need to actually make up a box plot. Those are the ones that are immediately shown to us when we are given a box plot. So the maximum is the furthest place, which it looks like that's going to be about 33. The minimum is the furthest place this way. Go down to the number line, that looks like 4. The median is the line inside the box. So there's the 2 lines that make up the box, and then there's the stuff outside of it. The line inside the box is the median, or Q2. So go down to the number line, that looks like that's going to be 13. So that's Q2. Q1 is the lower line that makes up the box. So that looks like that's going to be 10. Q3 is the higher line that makes up the box. So 20. The range, as before, is the largest value minus the smallest value. So in this case, it's going to be 33 minus 4, which is 29. And then the IQR, we said last time, is Q3 minus Q1. So that's going to be 20 minus 10, which is 10. The nice thing about a box plot is once you learn how to read it, you can get all of this information in a very short period of time. So as we talked about in the last video, each quartile holds 25% of all the data values in the set. So think quarter is 25 cents, so quartile is 25%. So that means that we can get some information from this. Below quartile 1 is 25% of the data, or 1/4 of it. Above quartile 1 is 75%, or 3/4 of the data. So looking up here, if this is 25%, the rest of it is going to be 75%. So quartile 1, everything below it is only 25% of the data, and everything above it is 75%. Below the median is 50% of the data, or half of it, and above the median is 50% or half of the data. And that makes sense, for what we know about median is that it is directly the middle point. So it has to be the thing in the middle. Now, looking at this, it might not look like the median is directly in the middle, but that's just because of how the data is spread out. In terms of when we actually go and calculate a median of a data set, it is in the middle. It just doesn't always look perfectly symmetrical. So what you need to know here is that from this dot to the line inside the box is 50% of the data values. And from this line to this dot is 50% of the data values. Q2, or the median, cuts it directly in half, even though it might not look symmetrical. And then below Q3 is 75% of the data, and above Q3 is 25% of the data. So Q3 has most of the stuff below it. If each of these chunks is 25%, I should have labeled that already. If each of these chunks is 25%, then yeah, there's only 25 below Q1, and there's 3 25s below Q3, which makes that 75%. And above it, there's only one 25% chunk. Further from this, the IQR is, again, Q3 minus Q1. It's the space between Q3 and Q1, and it makes up 2 25% chunks. So the IQR holds 50% of all of the data values. That might be a lot to take in, so we're going to get some practice with it. So looking again at the box plot above, what percentage of the data is from 4 to 20? So let's look here. 4 is our minimum, and 20 is our Q3. So that means that we're looking at all of the stuff below Q3, which, if we look up here, below Q3 is 75% of the data. Oops, sorry. Then we have what data values represent the lowest 25% of data. That's going to be from the min to Q1. So that's from 4 to 10. If there are 8 pieces of data from 10 to 20, how many pieces of data should we expect to be between 20 and 33 inclusive? That one's a little bit wordy. So if there are 8 pieces of data from 10 to 20, that's from our Q1 to our Q3. So 8 pieces of data. Because that's from Q1 to Q3, that is our interquartile range, and our interquartile range is 50% of the data. That means that 8 data points is half of what we have. And you don't have to write all of this either, but this is how my brain works through it, so if that helps you, by all means. So if 8 is half of the data points, how many pieces of data should we expect to be between 20 to 33 inclusive? So let's go back up, look up here. So from 20 to 33, that is our Q3 to our maximum. So that means that is 25% of the data. So one way you can look at it is, well, 25 is half of 50, so that means that this is going to be half of that. So 4 data points. And then lastly, what percentage of data values are greater than 13? So 13 is here, which is our Q2, our median. So anything greater than that makes up 2 25% chunks, which means it's going to be 50% of the data. Obviously, we'll get some more practice with that, but hopefully it's not too confusing. Not too confusing. Sorry, sometimes I repeat myself to make sure that the captions understand me. All right, last page of this. A scientist recorded the temperature in degrees Celsius in 12 different parts of a rainforest. Her results are as follows. So we want to find the interquartile range of the degrees. So our first step is we have to order the data from least to greatest and find the median. So let's see, our smallest is 8. Then we've got 10, and 10, 11 and 11, 12, 13, 14, 15, 17, and 21. All right. So now we have our data listed out from least to greatest. We have to find the median. So twelve is our median. Okay. So then let's see. That kind of cuts our data point, or our data set, in half. So the lower half is now 8, 10, 10, 11, and 11 alone. 12 was our middle point. Now we cut it in half, so our lower half is this. Our upper half is 13, 14, 15, 17, and 21. So we've split it in half. Now we have to find the median of the lower half and the median of the upper half by the same process. We do our cross, cross, cross. So 10, that's going to be our Q1. Cross, 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 cross. 15 is our Q3. So the IQR is just Q3 minus Q1, or in this case 15 minus 10, for an IQR of 5. This is another Keystone level problem, so congratulations. And then finally, the box plot below shows interest rates charged by different credit card companies. Now we've got a nice little box plot here. Instead of plain numbers, these are in percentages from 0% to 50% along the line here, but it'll work the same way. So our Keystone level practice problem here. A credit card company that charges 6% interest claims that their rates are lower than 75% of all other credit card companies. And we want to see if this claim seems correct based on the data that we have here, which is this box plot. So a 6% interest is going to be about there somewhere. It's above 5. Well, yeah, a little bit more towards the center of that, but you get the idea. It's above 5, but it's not quite to there yet. Sorry for my terrible drawing skills. So 6% interest is about there somewhere. And they're saying that their rates are lower than 75% of all other credit card companies. In order for it to be lower than 75% of the others, that means that it would have to be our quartile 1. Because each chunk is 25% of data. In this case, our data is credit card companies. So in order to be lower than 75%, it would have to be lower than all 3 of these. It would have to be right on the quartile 1, which is 5%. It has to be quartile 1 in order to have 75% be more than it. Q1 is 5%. 6% is, of course, higher than 5%, so no, this is false. It might have seemed like a more challenging question than it actually is. It was just asking us to see, oh, is 6% quartile 1? It's not? Cool. They lied. It is a false statement.